It's very rare that we have a fill in the blanks question, but let's do this together. So the scenario is a very interesting scenario that you must know. This is actually a transformer. This is the primary coil, and the magnetic field lines generated by coil P is linked to coil Q via this soft iron rod. And whenever there's a change in magnetic field that coil Q experiences, there will be an induced EMF induced current as per Faraday's law. So when the switch S is closed over here, momentarily when it's closed, coil P becomes an electromagnet, and this sets up a magnetic field that changes from 0 to a maximum value. Because of this strengthening magnetic field, which coil Q experiences, an induced EMF is therefore generated in coil Q, and because the circuit is complete, it will drive an induced current in coil Q, making the galvanometer deflect to one side. Now, when the current flowing in coil P is constant, there is no more change in the magnetic field lines linking to coil Q. So when there's no change, there's no more induced EMF, because Faraday's law requires a change in magnetic flux for there to be an induced EMF. Now, when we next open the switch in coil P, the current flowing in coil P decreases to 0. This means that the magnetic field that coil P generates also decreases to 0 quickly. This means that coil Q on the other side actually experiences this change in magnetic field lines, and therefore there will be an induced EMF, there will be an induced current, but now the direction of this induced current is opposite from before. The galvanometer needle therefore deflects to the other side. Same thing as before, when the current in the coil P remains at 0, that means you keep the switch open. There's no more change in any magnetic field strength, it just remains at 0. So therefore, there will not be any deflection in coil Q. Why do we use a soft iron rod? Is because we want to link the magnetic field lines from coil P all the way to coil Q, and the soft iron core allows us to concentrate the field lines and link it over without losing the magnetic field strength.